Alright, hello and welcome back to my real-time strategy in Unity tutorial. Hopefully this sounds alright because I'm using a new set of headphones because my old ones broke. That's fun. Anyway, today we are going to be doing sort of creating levels with Perlin noise. So it'll be, I want to say technically procedural, but you'll only have like a fixed area. It won't like go on forever. It'll just be, but you know, it's technically infinite. So I'll basically just show you it. Okay. So basically, as you can see, we've got areas of forest, grassland, stony bit, mountains. I know the art could be better, but whatever. I ain't Picasso. We've got water, which is unwalkable, and you know, you get the idea. There's a train going by, sorry. Yeah. And if I just zoom out, you'll see this is the entire map that has been generated. So you can imagine fighting over that, I guess. And if I just move the camera back down to the units that we have, I'll just select these workers and build a building. So let's build a storehouse here. And you'll see that it is all completely compatible with with everything we've done before. So all the pathfinding works, building buildings, selecting stuff, you know, all that good stuff. Yeah, and all like it generates resources as well. I will need to do some kind of farm building to get wheat, but you know, that can be done later. Yeah, just build another building as an example. So a temple. There we go. And you lot can do that. Oh, I have removed the effect for turning tiles turquoise around because I was using changing the sprite render color to get different variations on tiles, so that'd be why. Okay, so let's go over how this was made. Okay, so the basic idea of Perlin noise is that if we give this algorithm an x and a y coordinate, it will generate us a random, sort of pseudo-random, texture of like black to white pixels, as you can see in this first image here, which is a bit blurry and there's too many shades of intensity values for us to work with. But we can do some stuff with it. So basically, if we take these values and threshold them, so there's only a range of a specific number of like different intensity values from 0 to 1. So if we can see here, we've got 1, 2, 3, 4, 5, 6, 7 different values that the first image has been thresholded to. But you could do more, you could do less, you know, it's up to you. We're basically using this to act as a sort of like contour lines to denote how high or low a particular bit of land is. So if you can see, like it gradually gets darker here, so that would be representing a higher bit of the map, whereas the lighter bit is a lower. And what we do is we use that to represent, well, in this third image, we've used it to sort of denote, like, say, the lighter bits are lower down, so they might be below sea level, so there'll be lakes and stuff. And as it gets darker, it's getting higher, so we've got rocky bits to represent mountains. And the sort of medium-y grey bits, we've got like grasslands, forests, whatnot. And I'll just show you. So if you look at, say, the bottom left corner of this first coloured image, you'll see that there's a tiny bit of green here. There's also a tiny bit of green here in the bottom left of the screen, just below the original Perlin noise image. Yeah, so basically you can see that this map here represents the game map as a whole. So if just go over there, we can see this is the original lake that starts out in the bottom left corner. It's got its darker bits and lighter bits at the edge and whatnot. And as you can see, there's a mountain, some mountains near the top of it. We can see them. We'll go on, there's a smaller lake, and you get the idea. You could also do, like, change up the values. So I've done a separate algorithm that I've not turned into a map, but I've just drawn the texture of, say, you could have islands generated from it by just setting more values to being water. and the rest be like land and smaller mountains and whatnot. You know, it's completely up to you what you do. So yeah, that's basically how it works. We use Unity has a built-in Perlin noise function, so basically you just call mathf, just mathf.perlin noise, and it will just take your x and y coordinate and it will return this texture. But I basically actually you have to use I used this code provided by Unity in order to generate the texture. So that is full disclosure. I used that, but I will explain how it works sort of later. Aside from the Perlin bit, which I won't be able to explain, but it's not a proper Perlin tutorial. I'm just showing how we use it with making an RTS map. Okay, so onto the code. Okay, so first off, we've got two integers, which basically just define the width and height of the texture that you're going to get from the Perlin noise generator. So basically, I use it as a 1-to-1. So 1 pixel in the image is equal to 1 tile. Yeah, you can increase the size to get bigger images and whatnot, but keep in mind that the bigger it is, the longer it'll take. Sorry. We've got the x and y. Basically, if you provide different x and y coordinates, you get a different randomly generated pattern. Based on the scale, you might get basically the same patterns appearing in each other. So say if you had a scale of 1 and an x and 1 and a y of 1, you get a pattern. And if you had x2, y1, you get another pattern. But if you had a scale of 10, both of those patterns would be adjacent to each other inside the bigger pattern, but depending on the width and height, it might be smaller within it. So yeah. And number of colours is just number of colours that you want to have to threshold to. It will be +1, I think. And these are just textures I used to display the different Perlin noise stages. These colours are used the grass mountain and sea, which I didn't end up using, but oh well. These floats are used to define what is like mountains in the thresholded image, what's grass, and what's sea limit. So I used this range 0 to 1 basically lets us. Let's go to the grid manager. Basically, we've got sliders that go between 0 and 1, and basically, if a value, an intensity value for the grayscale image is less than 2.67, it'll be a mountain. If it's less than 0.55 and more than 2.67 or 0.267, it'll be grass, and otherwise it'll be sea. If you do like have them like this, you probably shouldn't because it'll break it a bit, but you could do if you wanted some kind of weird effect or whatnot. I don't know. So now we get just onto the initializing. Oh, we've also got a list, an array of pixels, which is used by the section of the algorithm I got from Unity, which is basically where they just store the original values for the Perlin noise. We got a list of colours, which is basically just a list of colours in the threshold, which we use when we're working out what tile to create. And the boolean to draw map is just whether to draw these textures on screen so I can demonstrate it, basically. First off, we've got the wait function, basically x and y is random number between 10 and 100. This will basically give us loads of different random maps, basically, that we can get. Isn't that good? Basically, it's just initializing things and setting the textures, so we don't need to worry about that. The one thing we need to use is the main method we use, for generating the maps in this bit. I know there's multiple methods, but these were just for drawing the different versions of the GUI version, the like image representation of it. For generating the levels, we use the thresholded noise only, which is referenced by the grid generator, but we'll get to that. So first off, we create a new noise texture of the pixel width and pixel height specified, and then we create a new array of colors called pix, or we just initialize that to be the noise text width and height. And then we go through each of these and basically this code from Unity, I believe it scales it so that so it's basically it'll use up the entire of the texture size specified, and then these coordinates are put into the mathf.perlin noise function, which returns a float value between 0 and 1, which we then use to create a grey scale color. So it'll be either from black to white, all three RGB values will be the same because it's grey. And this is then stored in the array. I don't know why it's this set thing, but it is, and I'm going to trust Unity on that. If you want to know more about how the Perlin noise works, you should probably research the documentation here. It probably says why. And yeah, so onto my bit. Basically, after we've set the pixels, we then go through the texture again. I just stored it into a separate local variable because it was messing with the other textures that we drew on the screen when I didn't. So that's not necessary, but it's there anyway. So go through each of these. So if we go through all the pixels, we grab the RGB values and the alpha values from the current pixel. We then multiply this by the number of colours. We then round this new number to a round it to the nearest integer, and then we divide it by the number of colours again, and we use this to create a new grayscale colour. Now this effect basically for all the possible intensity values in the Perlin noise image that we've generated, it will make them to be 1 out of the number of colours, plus 1, I believe. I've made a small script to demonstrate this, so hopefully it won't crash. It shouldn't. Well, the computer's been funny today. Wait for it to generate. There we go. So if I just clear that, press enter, and if you look at this, so basically we've got 0 to 0.9, and as you'll see, so 0x, so x is 0, x to 0 times 6 is 0, 0 rounded to 0, so 0 is now 0, so it's 0. 0.1 times 6 is 0.6, rounded is 1, and then 1 divided by 6 is 1.666667, and for 2 multiplied by 6 is 1.2, 1.2 rounded is 1, so 0.2 is now 1.666667. So this has thresholded both of these to be sort of like a dark grey colour, and a similar thing happens for 0.3, so it's 1.8, so it's rounded to 2, and that makes it 0.3333. 0.4 is rounded again to 2, so that's 0.333, and so on. So basically, each of the colours in the image is now one of 7 different grayscale colours, ranging from 0 to 1 in intensity. And we do that basically just to so we can have less data, so it's easier to read, and we can define these as regions or whatever for the terrain builder. And then once we do that, if the colour we've got doesn't exist in our colours and threshold list, then we add it, and then we set the pixel. And once we've gone through all the pixels, we will then sort the colours, apply it to the texture, and return the texture. Now for the sorting, we do this because we want to have a list where we can assume that the darker colours will have a lower index value and the lighter colours will have a higher index value. So basically pass in the list of colours that we want to sort, and we grab all the grayscale values, which are just a float between 0 and 1, and we add them to a list of floats, and then we can just use the intensity values.sort on them, and we'll have a sort of sorted list of these grayscale values. And then we grab the original list of colours and we put them in a new list called ordered list. But we're only adding them if we can find the value in these intensity values that we ordered. It will find all of them, basically. Don't worry about that. But let's just make sure that they are in the correct order, because we can't sort by colour or intensity value. So we have to do this little workaround type deal. So yeah, just quick check. Right, so we got that. Threshold noise. Yep, done sorts and colours. Now onto the grid generator. Basically, one different change, a couple of changes. We've got a couple of new types of tile, which I'll go over in a second. And for generate grid, we basically now get a thresholded noise texture. So that'll be the one with basically the one with 7 different colours of grey values instead of lows. Then we set the grid dimensions to be the width and height of this texture that we've just gotten. Then we go through all the pixels in the texture, and we call this method called getTileFromColor, the current pixel, which is basically a method I wrote to decide what kind of tile we want to get based on the mountain, grass, and sea limits, and the colour of the pixel. So yeah, and that's it. I'll just show you the getTileFromColor. Basically, first thing we check if it's less than the mountain limit, or more than the mountain limit, and less than the grass limit, or more than the grass limit and less than the sea limit, to decide whether it should be grass, mountain, or sea. And then once we're in there, we check if it's more than the first. So we basically do a check on the colours to work out what kind of mountainous terrain we want it to be. So if it's more than or equal to the first colour, or less than the first colour. So in this case, colours in Thresh 0 will probably be black, and colours in Thresh 1 will be like dark grey. So if it's completely black, then we want to return the mountain. So this would be like an unwalkable patch of terrain that units can't get through. And if it's not that, so we'll assume that it's either this colour or above, so it'll be the dark grey. We return rocky, which is basically a new type of tile. We do a similar thing for the grass, so if it's above the mountain limit and less than or equal to the grass limit, and it's more than or equal to colours in Thresh 3, then we return grass, otherwise we return forest. And a similar thing for the sea, as you can see. And if all else fails, we just return the prefab tile. So say if it had values above the sea limit, which shouldn't happen, but it could do, then we return the prefab tile, which is just dirt. Otherwise, if it doesn't meet any of these conditions, like in some kind of horrible case scenario where the setup was wrong or something, you have to return just the prefab, just so it has something to return. Okay, that was fourth take, but it worked. And now I've added a couple of new tiles just to add resources into the game. So basically I've got a forest tile, which basically has a 40% chance of generating a tree and has a higher F cost. So if, like, when drawing the paths, the units would try and avoid the forest because, it's dense, it's hard to get through and stuff, easy to ambush in. So we're just multiplying the F cost by 10, just to so units will go through the forest, but they will try and avoid it if they can. Similar thing for Rocky, we basically have a random number between 1 and 100. If we've got a 5% chance of spawning any kind of resource on that particular bit of rock. Then we get another random number between 1 and 100. If it's less than 50, we spawn normal stone. If it's less than 90 but more than 50, we spawn iron. And if it's more than 90, we spawn gold. And this third random basically just gets us a different like looking rock each time, because we have 3 different types of each rock there. I don't do it for the tree, but yeah. So let's just give you a quick demo. Here. So yeah, this will be quick. Well, basically, that's just it. There's a couple of issues that will have to be addressed first. So if I just select these guys and actually I'll just remove him. So this guy. So say we have this dude here, and go into the game. So I've got this unit selected now. Say we wanted to move him across the map. So we wanted him to move from one corner to, say, here. You'll see that the game hangs because we got, I think it's ridiculous. We got quite a large number of tiles now. So I think it's 250 by 250. So I've got 62,500 tiles in the scene on its own, and it takes a while for it to draw the bloody path, because it's got to wait for the path to be returned, and it's quite intensive to search through 62,000 odd tiles. Yeah, and that will be a problem that we have to address. I've got a couple of ways that we could fix the problem, so that will be in the next episode, along with some other improvements which have escaped me at this time, but we'll come back in a second. So yeah, cheers for watching. Like, comment, subscribe, all that shit. Just again, you can see we got this kind of land for creating randomly. You can see he's actually managing to go to where he wants to go. He's avoiding the sea. He's trying to stick to grasslands because I've specified that forests have more higher F values, so it takes longer to get through. And yeah, he's got that. So yeah, cheers for watching. Like, comment, subscribe. Go check out my stuff in Itch.io. Been working on Loud or Quiet, actually putting a new pause menu, which is not up on Itch.io yet, but will be at some point. Yeah, it's all going swimmingly. I've got 2 weeks left in university, 2 exams, and I'm fucking terrified. So, buy my shit. Stop me having to get a proper job. Thank you. Have a good one.